Hello everyone, welcome back to the problem solving playlist. So first data structure or tool which we will be looking at is called stack. So what stack is? So stack is a linear data structure which follows this very special property called last in first out, or in short LIFO or LIFO. So what this last in first out property means? So let me draw down one stack. So a stack can be imagined as a data structure which looks like this. Okay, so whatever element we are inserting will be storing like this. Here we are suppose inserting A, then inserting B, then inserting C. So it stores like this, one top of another, one top of another. So this operation is called push. So what are the main functions we will perform on stack? One is push, one is pop, and another is peek. These are the main three essential functions which we are going to perform on stack. So this operation is called push. Then whenever we have to remove one element from stack, that operation is called pop. So one special property is we can only pop elements from top of the stack. So what is the top of the stack? The top of the stack is this. This is called top of the stack. So we can only remove the top element. So for removal of the top element, we can see the C is the last inserted element, and we are removing it at the first place. So that's why it's last in and first out. So when we pop it, then we will get C. When we pop it, we will get B. When we pop it, we will get A. So notice one thing. While insertion, we have inserted in this order A, B, C, and while popping we get CBA. So it's just the reverse. So this is one key thing you have to keep in mind that will be beneficial afterwards in this lecture. So what is now this peak operation? This peak operation is, it will simply return the top of the stack value. So if we have a stack like this where we have stored A, B, C, and we do a peak, then it will return the top of the stack, which is this value. Is simple, like uh, I mean, we are picking at the top of the stack and we are seeing the value. So these are the very basics of stack. You can go in depth on how to implement stack, or I will be showing you how to implement the stack at very basic level. But mainly we will focus on what are the use cases this stack is used. So the uses I have written down. The stack is mainly used when we have to keeping track of something or keep the history of some sort. So what this keeping track or keeping history means? Let's suppose we have done some operation and we have diverted from that operation to another operation, and we have to come back to that operation once again. So what operation is done just before the exact operation or current operation we are at? How can we keep track of that? We will be keeping track of that using stack. So one very practical example is in DFS, in depth first search. In DFS, what we do, we use a stack. In DFS, when from one node we go to its adjacent node, and from its adjacent we go to its adjacent, and when all its adjacent are visited, we have to come back to this node, right? So how come we know that the previous node of this node is this node? So that's why we use a stack to keep track of every previous node of each node. So that's when a stack is very useful. Another useful use case is in recursion. As we know, recursion is a function calling itself. So let's suppose a function f is calling another function f and f. Now it's calling again a function f and f. I'm not writing down the parameters over here. Let's imagine something, any parameter they are having, and these are the base cases of this function. So from here it has to return some value to hit this function, right? So how come our program knows that this function has to return the value to this function? So here a call stack is used. So it will keep track of every function call and its previous function call. So this is also a very useful use case of stack. And last of all, when we want the element in reverse order, as I have shown over here, we have inserted ABC and we are getting after popping CBA. So when we need some use case, like we are inserting in order and we are removing the elements and we want the reverse of order, so then we use the stack. So one very basic program we can do, like reversal of a string or reversal of a number. using stack. We just push the elements, and after that, if we pop the elements, it will be in reverse order. So these are the main use cases of stack. So let me go to the computer and show you how to implement stack using Python. Now we are the code editor. I'm using Visual Studio Code over here. You can use any of the IDE. So this whole problem solving playlist or course will be in Python, but each concept I will be describing over here can be implemented using any of the language you want. So first of all, we will be implementing stack over here. So I have also written down the same points I have just mentioned in the whiteboard. It's LIFO, and we have mainly three functions: push, pop, and peek. And we can also use a function called length, which will eventually give us the length of the stack. So that is pretty easy. Like, it's similar to calculating the length of any, length of any array. So these are the main functions, and these are the main use cases. So in Python, we can implement stack using a list. So we all know who code in Python what a list is. It's basically a dynamic array where we don't have to specify the size of it. So you can implement this specific data structure in other languages like C or C++, in Java, using the orthodox array, or you can also use linked list to implement stack. So that's a different part of study, but we are not focusing on mainly implementing the stack. We are focusing more on how we can use the stack. So for implementing purpose, you can go through Google and search it. And let me tell you that both in Java and C++, there are built-in modules for stack, like in C++, STL, and Java collection. So you can always use them without implementing stack. So, but knowing the basic implementation is obviously important. So after knowing implementation of stack, do it once yourself, and then you can use the built-in functions over there. And we will be using Python over here. So let me initialize a list called stack over here. So let me call it a stack. So it's first empty. Okay. So now we have to insert some elements into it. So how we can insert element? So in Python, we have this method or function called append. So what it will do is exactly what stack is supposed to do in its push operation. It will insert the element in the stack, and after the second insert, it will insert the element just on top of the previous element, and it will do so on. So first of all, let me insert 1, and let's just copy this and insert some more element. Let's insert 3 elements. Okay, so 1, then there is 2, and then there is 3, and let's print the stack. Okay, print the stack, save it, and run it. So let's see how we are getting the output. We are getting it like 1, 2, and 3. Okay, so it is maintaining the order 1, 2, and 3. So after that, if we have to pop the element from the stack, from where we have to pop. We have to pop from here, because this is the top of the stack, right? First 1 is inserted, then 2 is inserted. Just imagine this as the picture I have drawn on the whiteboard. This part is open and this part is closed, and we are inserting element like this. First 1 is inserted, then 2 is inserted, then 3 is inserted. And if you have to pop, because this part of the stack is open, so we have to pop from here. 3 is popped first, then 2, then 1. So for popping operations, we have a function very logically named that is pop in Python, pop. So what this pop function will do is basically pop the lastmost element from the stack, or rather the top element from the stack. And after removing the top element, if we print stack again, we will see we are only left with 1 and 2. So here you can see first it was 1, 2, 3, then it is left with 1 and 2. So these are very basic stuff like push and pop. And afterwards, when I will be showing you some real world examples using stack, then it will be very interesting for you. So these are the very basic things. And now let me show you also the peek operation, how to do the peek operation in Python. So for peek operation, we have to print the last element of the list, or rather the top of the stack. For this purpose for this case. So the top of the stack can be accessed as -1. In Python, -1 means we are pointing at the last element of the list. So for here in this example, if we print this, we will get what? 2, which is top of the stack, or rather we can say the last of the list. So this is the pick function for our use case. So again, let me run it and it's working fine. So this is pretty much it about how to implement stack and what are the scenarios when we use a stack. So I will be showing you some problems based on stacks and why we are using stack in those problems, so you can get a better understanding. So thank you for watching and do stick around for more. Goodbye.